The National Electrical Code, or NEC, provides guidelines for grounding metal tanks, which implicitly includes butane gas tanks. NEC Section 590.4 mandates the grounding of all metal tanks. When dealing with Class I, Division II locations, NEC Sections 501.10c and 502.10c stipulate that all non-electrical equipment, such as gas tanks, must be grounded to prevent static electricity buildup. The grounding method should adhere to guidelines outlined in NFPA 77, which is a recommended practice on static electricity. A grounding resistance of less than 25 ohms is generally recommended. To achieve this, utilize a copper-clad ground rod that is at least 8 feet long, driven into the earth. Connect the tanks to this ground rod using a minimum of number 6 American wire gauge, or AUG, bare copper wire. It is also important to bond the tanks to other grounded equipment in the vicinity, such as the 480 volts disconnects, again using a minimum number 6 AWG bare copper wire for bonding. The ground rod should be placed near the tanks but not directly underneath them. If feasible, install the tanks on a non-conducting surface, like concrete or asphalt, to further minimize the risk of static charge accumulation. Install warning signs to alert personnel about the potential static electricity hazard. Routinely inspect the grounding system for any signs of damage or corrosion to ensure its continued effectiveness. Grounding is essential for preventing static electricity discharge, which can be a significant hazard, especially in environments where flammable materials are present. The NEC provides the minimum requirements for electrical safety, and NFPA 77 offers guidance on managing static electricity hazards. Understanding these standards and implementing appropriate grounding and bonding practices are crucial for maintaining a safe working environment. For grounding, begin by selecting a suitable location for the ground rod, ensuring it is accessible for inspection and maintenance but not directly beneath the tanks. Drive the 8-foot copper-clad ground rod into the earth until it is fully submerged, leaving only enough exposed to facilitate the connection. Prepare the number 6 AWG bare copper wire, ensuring it is long enough to reach from the ground rod to each of the tanks. Use appropriate connectors to attach the copper wire to the ground rod in the tanks, ensuring a secure and corrosion-resistant connection. For bonding, run a separate number 6 AWG bare copper wire from each tank to the nearest grounded equipment, such as the 480 volts disconnects. Again, use appropriate connectors to ensure a secure and corrosion-resistant connection. Measure the grounding resistance using a ground resistance meter to verify that it is less than 25 ohms. If the resistance is too high, consider driving additional ground rods and connecting them in parallel to reduce the overall resistance. Regularly inspect the grounding system for any signs of damage or corrosion, paying particular attention to the connections and the condition of the copper wire. Replace any damaged or corroded components promptly. Ensure that warning signs are prominently displayed in the area to alert personnel about the potential static electricity hazard. These signs should clearly indicate the presence of flammable materials and the importance of grounding. Implement a regular maintenance program for the grounding system, including periodic inspections and testing to ensure its continued effectiveness. Keep records of all inspections, tests, and maintenance activities. Ensure that all personnel working in the area are trained on the hazards of static electricity and the importance of grounding and bonding. Provide training on the proper use of equipment and the procedures for reporting any potential hazards. The grounding system should be designed and installed by qualified personnel who are familiar with the NEC and NFPA 77. Ensure that all work is performed in accordance with applicable codes and standards. Consider consulting with a qualified electrical engineer to ensure that the grounding system is properly designed and installed. Document all aspects of the grounding system, including the design, installation, testing, and maintenance. Keep these records readily available for inspection. The grounding system should be reviewed and updated periodically to ensure that it continues to meet the requirements of the NEC and NFPA 77. Consider the specific characteristics of the soil in the area when designing the grounding system. Soil resistivity can affect the effectiveness of the grounding system, so it may be necessary to use additional ground rods or other measures to achieve the desired grounding resistance. In areas with high soil resistivity, consider using chemical ground rods, which contain chemicals that leach into the soil to improve its conductivity. Ensure that the chemical ground rods are installed in accordance with the manufacturer's instructions and all applicable codes and standards. Consider the potential for lightning strikes in the area when designing the grounding system. Lightning protection systems can help to protect equipment and personnel from the hazards of lightning strikes. Ensure that the grounding system is properly integrated with any lightning protection systems. Consider the potential for stray currents in the area when designing the grounding system. Stray currents can cause corrosion of underground metal structures, so it may be necessary to take measures to mitigate the effects of stray currents. Ensure that the grounding system is properly coordinated with any cathodic protection systems. Consider the potential for electromagnetic interference, or ME, in the area when designing the grounding system. Proper grounding and bonding can help to reduce EMI. Ensure that the grounding system is properly designed to minimize EMI. Consider the potential for harmonics in the electrical system when designing the grounding system. Harmonics can cause overheating of equipment and other problems, so it may be necessary to take measures to mitigate the effects of harmonics. Ensure that the grounding system is properly designed to minimize the effects of harmonics. Grounding is an essential safety measure that helps to protect personnel and equipment from the hazards of electrical shock and static electricity discharge. By following the guidelines in the NEC and NFPA 77, you can ensure that your grounding system is properly designed, installed, and maintained. Remember to regularly inspect and test your grounding system to ensure that it continues to provide effective protection. Static electricity is a common phenomenon that can occur when two materials come into contact and then separate. This process can transfer electrons from one material to the other, creating a static charge. The buildup of static charge can create a potential difference between the charged object and its surroundings. If the potential difference is high enough, a spark can occur, which can ignite flammable materials or damage sensitive electronic equipment. In the context of butane gas tanks, static electricity can be generated by the flow of butane through the pipes and fittings, or by the movement of the tanks themselves. If the static charge is not properly dissipated, it can build up to a level where a spark can occur, which could ignite the butane gas and cause an explosion. Grounding provides a path for the static charge to dissipate safely to the earth, preventing the build-up of a potential difference and reducing the risk of a spark. The grounding system should be designed to provide a low resistance path to ground, allowing the static charge to flow easily to the earth. The NEC and NFPA 77 provide guidance on how to design and install effective grounding systems for butane gas tanks and other equipment in hazardous locations. In addition to grounding, bonding is another important technique for preventing static electricity hazards. Bonding involves connecting two or more metal objects together to equalize their electrical potential. This prevents the buildup of a potential difference between the objects, reducing the risk of a spark. In the context of butane gas tanks, bonding can be used to connect the tanks to other metal objects in the area, such as pipes, equipment, and structural steel. This helps to ensure that all metal objects in the area are at the same electrical potential, reducing the risk of a spark. The bonding system should be designed to provide a low resistance path between the objects, allowing the static charge to flow easily between them. The NEC and NFPA 77 provide guidance on how to design and install effective bonding systems for butane gas tanks and other equipment in hazardous locations. Grounding and bonding are essential safety measures that help to protect personnel and equipment from the hazards of static electricity discharge. By following the guidelines in the NEC and NFPA 77, you can ensure that your grounding and bonding systems are properly designed, installed, and maintained. Remember to regularly inspect and test your grounding and bonding systems to ensure that they continue to provide effective protection. Consider the specific hazards present in your industrial manufacturing process when designing your grounding and bonding systems. Butane gas is a highly flammable material, so it is important to take extra precautions to prevent static electricity discharge. Ensure that all personnel working in the area are properly trained on the hazards of static electricity and the importance of grounding and bonding. Provide training on the proper use of equipment and the procedures for reporting any potential hazards. Consult with a qualified electrical engineer to ensure that your grounding and bonding systems are properly designed and installed. Document all aspects of your grounding and bonding systems, including the design, installation, testing, and maintenance. Keep these records readily available for inspection. Review and update your grounding and bonding systems periodically to ensure that they continue to meet the requirements of the NEC and NFPA 77. By taking these steps, you can help to ensure a safe working environment for your employees and protect your equipment from the hazards of static electricity discharge. Firstly, verify the classification of the area where the butane tanks are located. The classification is Class I. Division 2 indicates the presence of flammable gases or vapors under abnormal conditions. Secondly, ensure that the grounding system complies with all applicable codes and standards, including the NEC and NFPA 77. Thirdly, use only approved materials and equipment for the grounding system. Fourthly, install the grounding system in accordance with the manufacturer's instructions. Fifthly, test the grounding system after installation to verify that it meets the required resistance. Sixthly, inspect the grounding system regularly for any signs of damage or corrosion. Seventhly, maintain records of all inspections, tests, and maintenance activities. Eighthly, train all personnel working in the area on the hazards of static electricity and the importance of grounding. Ninthly, review and update the grounding system periodically to ensure that it continues to meet the requirements of the NEC and NFPA 77. Tenthly, consult with a qualified electrical engineer to ensure that the grounding system is properly designed and installed. Static electricity can accumulate on objects that are not properly grounded. This accumulation of static electricity can create a potential difference between the object and its surroundings. If the potential difference is high enough, a spark can occur, which can ignite flammable materials or damage sensitive electronic equipment. Grounding provides a path for the static electricity to dissipate safely to the earth, preventing the buildup of a potential difference and reducing the risk of a spark. The grounding system should be designed to provide a low resistance path to ground, allowing the static electricity to flow easily to the earth. The NEC and NFPA 77 provide guidance on how to design and install effective grounding systems for butane gas tanks and other equipment in hazardous locations. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer to ensure that your grounding system is properly designed and installed. Proper grounding and bonding are crucial for safety in industrial environments where flammable materials are present. By following the guidelines in the NEC and NFPA 77, you can help to protect personnel and equipment from the hazards of static electricity discharge. Always prioritize safety and take all necessary precautions to prevent accidents.